Okay. All right. Welcome to the KubeStellar ContribFest. My name's Andy Anderson. This is Paolo Dittori and Franco Stellari, colleagues from IBM Research. And today we're here to talk to you about contributing to KubeStellar. And we'll get started here. So our project is enjoying a bit of an increase in the number of stars and forks. So I think as of today, we're up to about 365 such stars. If you wouldn't so mind, please go ahead and press a star if you can and give us some love. We just went through a remodel and reshaping of our UI for our web page. And so just bring across our slogan, don't change anything, just add KubeStellar. Okay, I'll play our, I don't think, do we have sound in here? Let's see. Through the, we can do that. That's okay. Oh, is it?
I should have asked you. It's my fault.
Oh, that's all right.
Where's your headphones?
I'll get it. Just on the other side.
Oh no, dove sono i miei gattini? Here we go. Finalmente sta funzionando, grazie KubeStellar.
All right, so that video is one of the infamous infomercials that we've been recording over time. And our first one debuted about 2 years ago. This one's just fresh off the presses. Our world premiere was here at this KubeCon. So you saw it was mostly space themed, of course, right? So the idea here that we're trying to drive home about KubeStellar is its ability to, it's not only simplistic to use, but it allows you to centrally define workloads that you want to put out on remote clusters that might suffer from disconnection, or that disconnection might be intentional. So that's how we differentiate ourselves from a lot of the multi-cluster solutions that are out there today in Kubernetes land. So you use standard tools, right? And the things like kubectl, Helm, Argo CD, et cetera, to deploy your workloads across these disconnected clusters or connected, depends on your scenario. We allow for scalability. A lot of one-to-many or many-to-one scenarios can be covered with KubeStellar. And of course, its modular design lends it nicely to be integrated with just about anything in the Kubernetes landscape, especially all the CNCF projects that are out there. Okay, so how do we accomplish that? Well, one of the ways that we do this is through use of a reduced API instruction set, and that API instruction set is inside of what a vCluster. And so you're basically installing a cluster within a cluster. So imagine for a second, if you were to run the API resources on a default Kubernetes cluster, you'll see that you'll get a little north of 280 APIs that are available. In KubeStellar, what we did is we reduced that down to 40. And so what that does is it reduces or restricts the types of things that you can deploy on the KubeStellar core, but it doesn't restrict those things from being deployed to remote workstations or remote clusters that are integrated and part of the inventory for KubeStellar. Okay, so that's really kind of the secret sauce there. So what you'll notice is when you deploy a workload into KubeStellar core in what we call staging, you'll notice that when that workload's deployed, you'll see no pods or jobs will start as a result. That's because those APIs don't exist. We cover deployment service accounts, config maps, everything, but just those specific APIs are removed. Okay, so that allows you to deploy to just about anything and everything, right? We're just a layer on top of what you already currently have. So there's no real adjustment that needs to be made to any of the current integrations that you might have already in cluster. You, like the slogan says, you don't have to change anything, just add us. All right, so I oftentimes use a Venn diagram to describe how KubeStellar accomplishes this. And so it's a couple easy steps, right? First is we have inventory, workloads, and binding policy. So you can see the crossover between them is what's actually going to be applied to your remote workers. Okay, so we'll start off, we register and label our clusters. So this is a fairly new concept for most people that don't use something like KubeStellar. You're not labeling nodes, you're labeling clusters. So that's a little adjustment that you have to make about the way you're thinking about how KubeStellar works. So for instance, I would label a cluster my inferencing cluster or my fine-tuning cluster or my training cluster or something of that nature. Okay, and then I would move to stage my workloads. So these workloads here, I might put a VLLM container out there, deployment, or maybe it's something having to do with a llama, something like that. But again, the pods won't spin up in this capacity until they are matched by the binding policy. So I put my binding policy together, and what I simply do is say, the workload that's labeled X is going to go on the cluster that's labeled Y. That's it. So what's really cool about this is at any given time, if I need to adjust the workloads across these clusters that I'm managing, I simply change the label. Workload removes itself from being deployed on one remote cluster and moves to another. So it really takes advantage of the labeling methodology that's inherent in Kubernetes. All right. So that's a brief overview of what KubeStellar does in a nutshell there. But why you're here? Well, how can you help us? Well, first, I mentioned that you could start our repository. That would be a great start. But in KubeStellar land, this is essentially what we have here. We have a demo environment that you can run quite simply and quickly with a bash to curl instruction. And you grab this right off of our getting started page. This will run through and grab all the necessary components that you need in terms of Helm charts, check for their version numbers, and then set up what we have today. We can work with any type of cluster that's out there, but for this specific purpose, we use kind clusters. So we set up a couple of clusters inside of kind. Two of them are designated as remote clusters, and then we set up things from there. All right, and I'll just fast forward a bit through this. Whoop, I fast forwarded a bit too much. Okay, so when you're all said and done, let's see if I can get to the end of this. What you'll see is this output. And this takes roughly about 8 minutes. Okay, once you get your complete, you've got what we call an inventory transport space, a workload descriptor space, and some remote clusters, and then the contexts that match each of those. Once that's set up, now you've got regular CRs that you can apply to make changes and use KubeStellar. Okay, so moving on. If you would like to, for next year, or even for potentially in North America or in Amsterdam next year, we're looking for takers to build a new infomercial for us. We're thinking maybe a Marvel superheroes is the next step for us. But beyond that, in all seriousness, we do use some of the famed CNCF tool set that's out there, web pages specifically, Clo Monitor. We're ranked 93% right now, which is, I think, a fantastic ranking for a project in the CNCF sandbox. We're up there with some of the top ones. You can see security, we're lagging a little bit behind, but it's only for the sake of having signed releases. We are working on that right now. There's a PR making its way through. So if you'd like to join in and help out with that effort, we applaud your effort and we'd love to have you work with us. Okay. So also we have what's called good first or help wanted issues. Those are all listed in something called contributor.io. And contributor.io, we have a number of issues that are listed there that would be good first issues in terms of learning to work and use KubeStellar out of the box, as well as how to enhance it going forward. So those are two places where you could look to find out more. New for this KubeCon, we worked with the CNCF. They have an LFX internship program. which has been an incredible boost to our productivity. We were able to put out 6 project ideas and garnered over 420 applications for the same. So you can imagine the difficulty in trying to weed through all those. The way we do it is if you want to come work with us, we're happy to have you, but we'd like you to put in a PR or two to show us if you understand, A, if you understand Kubernetes, B, if you understand KubeStellar and our goals and mission, and C, if you can come up with ideas of your own without a lot of extra hand-holding, let's put it that way. So this user interface that I'll show you in just a second was put together by 6 interns over the course of 45 days. I was blown away by the speed with which that they used to get this done. So I'll give you a quick little look at what this looks like. Okay. So right now I'm running this on the local client cluster. Let's see, that's only sharing that. Oh, I'm in presentation mode, huh? Let me stop the slideshow. Okay, yeah. All right, so here we are. Something that's cool. You don't have to tell anybody else that you can do that, but I like that. Okay. All right, so this username password stored in a secret and a config map. So everything you're seeing here is driven by config map secrets and the KubeStellar underlying infrastructure that's laid down, the environment. So I'll take you through. So again, as I stated, you're basically setting up registering clusters and then you're labeling them, okay? So that's step 1. So we made that step 1 in the user interface as well. You can dig that out of your kubeconfig, or you can just put in an API endpoint and a token, or you can use the manual operation to generate a command that will give you a cluster ADM command. So cluster ADM is part of the open cluster management initiative upstream of Red Hat Advanced Cluster Manager, which we incorporated and use. So we leverage other CNCF projects that are out there that have had success in this space. So that's our so-called agent, if you will. So you can generate the command and run it on a command line in the context of that cluster. It'll register the cluster to this list. And then from there, you can label. Again, labels being very important on this. Second step, of course, is then to add a staged workload. You can do this from a YAML file, all right? So I can put in a number of, I can put a namespace, a deployment, a service account, et cetera in here. I can grab it from a file. From GitHub, we're actively adding more from popular repositories. Helm is another place. Go grab something right out of the Bitnami collection, say like Drupal or something like that, and go ahead and apply. And this will work in the background, do its thing, and in a matter of a little bit, maybe a minute, probably less than that, a couple of seconds, you'll see it actually show up. Yeah, so there it is. It's actually deployed. And so now it is what we call staged, okay? So what you're going to notice about a workload that gets staged, all right? When a workload is staged, you'll notice that there's no pods on it at all. So that's what I was mentioning before. And this seems to be suffering loading a tree. All right, let's move on. All right, so the next step after getting the workload staged, oh, it just showed up, didn't it? Come on, there you go. Okay, good. So now if we scroll there's Drupal. So you'll notice here, right, you've got your service account, your secret, you've got your deployment in here somewhere, there it is, your stateful set, okay, and then we go all the way down to the replica sets, endpoints, and then on this right-hand side, no pods, no jobs. Okay, so now it is officially staged. It's not taking up any compute, memory, or storage, and then we go in and we create a binding policy. Now we're going to tie the cluster to the workload, or the workload to the cluster, whichever you prefer. Then we came up with a drag and drop like interface. It is drag and drop, not like, but it is. So we add our clusters. Pretty soon this is going to be labels from clusters on the left. That'll change slightly. And then we could go ahead and add Drupal to the right. We'll do Nginx for now. Okay, so I'm going to deploy that binding policy. And once it's deployed, we're going to look on the remote. And on the remote, you'll see this is what shows up. Okay, So now, instead of just having those staged workloads that have no pods assigned to them, now we have pods running. And you can look at the details of that pod. You can delete it. It'll redeploy it. You can look at the logs that are inside of it. You could change details about it, et cetera, et cetera. So this is brand new for this year. And like I said, these folks work incredibly fast, and we're really proud of them. And I'll give them a shout out later on. So there's a couple of opportunities we have for you here. Not only you can contribute for free, and that's all well and good, but we can also pay you to contribute. How does that work? So this is really important. The CNCF, and this is an incredible opportunity for those of you who are out there, or for those of you that are know others that want to do. If you're part of a university program, you're currently in academia, or even if you're outside of academia, there's two programs that are really important to know about. The first is the Google Summer of Code, and that takes place on a yearly basis, of course, in the summer. It's about a three-month-long program. We get the opportunity through the CNCF to apply for that and become instantly registered. So we don't have to fight for a position in Google Summer of Code. To be honest, I missed the deadline to register on Google Summer Code natively by 30 seconds. I kid you not. They were on the European time zone, and I was trying to. We're going by GMT, and I was going by Eastern time zone in the U.S. But I got in through the CNCF. So this summer, we're looking for someone to come on board, or two people to come on board and help us out with some project ideas we have about scalability and performance for KubeStellar. And we'll add that as a plugin to our user interface. The second one that I'm showing here is the internship project idea. So this is formally run by the CNCF. It's an LFX internship program. They actually pay the interns on our behalf. So we go out, recruit, ask for interns. They submit applications to come work with us, and we do that through form of PR. And once they're picked and selected, the CNCF gladly pays them a weekly stipend. It's an incredible program. We don't pay a dime for that, but as a part of the CNCF Sandbox project, we get to use that program. It's fantastic, and that's where these folks came from that built this UI. We're going to be doing this 3 times a year. Spring is the first time that we've done this. The second one will be the summer, and of course the fall. In the summertime, we're looking at an AI chat plugin that'll help you stage your workloads appropriately or configure binding policies. We're also looking at a backup plugin. You know, after you've installed all these things in KubeStellar, it would be nice to have that backed up. So native use of etcd for that. And a label manager. We're starting to understand more about how people are using multi-cluster, and the idea of KubeStellar brings to mind a couple things. So the analogy that I like to use is that a KubeStellar master is to a worker node as a KubeStellar core is to a remote cluster. Okay, so you got to take a minute for that to sink in, because we're treating full-blown clusters as worker nodes, if you think about it. So this idea of labeling clusters, what labels should go on those clusters, how should those labels be applied, right? And how should workloads heed those labels? It's an interesting dilemma. If you have built for purpose clusters nowadays, you're noticing that more and more there's GPUs in one, there's memory in another, there's storage in another. That's starting to fragment quite a bit. So we need to help people get over that. Of course, notifications for offline over a certain threshold, of course, because we do manage to do disconnected operations pretty well. And a plugin marketplace. I mean, everybody's got plugins, right? But Artifact Hub from the CNCF has been gaining a lot of popularity, and we think we could probably have our own category in there. So something like what you see for Headlamp or other vendors in that space. Okay? And of course, we always maintain in our issue list a help wanted tag. So you're free to get that as well. All right, let's see. I think we're going to pass on. So up next is one of my esteemed colleagues, Paolo Vittori. He is the mastermind not only behind KubeStellar, but also KubeFlex. He's a fantastic person to work with, and he's going to take you through a little bit more about what KubeFlex is, how it works under the covers with KubeStellar, and how it's going to be used in the future to help us build more of these built-for-purpose control planes, small ones. Thank you, Paolo.
Thank you, Andy, for the introduction. Talk a bit about KubeFlex. KubeFlex is one foundational component in Stellar.
You want to do it?
And so the main reason, if you look at the architecture of KubeStellar, you really talk about how KubeStellar works and what we can do with KubeStellar. So the main goal, as you know, as we described, is really to deliver workloads to clusters, to manage clusters from a central hub cluster or core cluster. So in order to do that, we essentially have this concept. Oh, thank you.
Got the mic you up.
Thank you. So I have this concept of what we call spaces, right? So we have a notion of a workload definition space where a user can apply the workload using standard Kubernetes API, standard Kubernetes tools, kubectl apply, the usual model to apply a workload like a deployment, and also to define policies, as Andy was mentioning before, where policies that essentially say what goes where, right? That's pretty much what the user will do with those spaces. And we can have multiple, because a space can represent also a collection of clusters. So there may be resources that are cluster scoped. An example are CRDs, namespaces, etc. And having just one single WDS may not work if you want to manage a disparate collection of clusters. So that's really the reason why you see multiple workload definition spaces there. And then we have also this notion of inventory transport space. And that's really the space that takes care of delivering the workload to the managed cluster and maintain an inventory of the managed clusters. User will interact with some kind of inventory API. There is some effort in standardizing currently in SIG multi-cluster the inventory API. And we are relying actually on another CNCF project that is called Open Cluster Management for this particular feature of transport and inventory. And OCM actually use this API from SIG multi-cluster that is emerging. We also use this SIG work API, that is the API essentially that represents the workloads to apply to the different clusters. So that's pretty much it for the architecture. So we have this notion of space. Essentially, what is a space in this concept? The box that we see on the left. These are really representing API servers in Kubernetes, and access controllers, potentially controllers that goes together. That's what really they are. And indeed, if we talk about KubeFlex, KubeFlex is intended to be more a kind of separate module. It could be also used independently from KubeStellar. But while we are building KubeStellar, we also felt the need to have something like this. And we actually we use mainly for KubeStellar, but in theory, we can use also for other use cases, right? And why something like this? Because essentially, we need a way to manage these spaces, a way to provision essentially an API server, a Kubernetes API server, with some controllers. And this is not a full cluster. Now, if you're thinking about vCluster, some folks may be familiar with vCluster. Right? vCluster is trying to sort of virtualize a whole Kubernetes cluster, take this cluster and create sort of virtual cluster inside, right? Here, we actually also can run vCluster kind of spaces inside, but we also run more lightweight API server and controller. So we don't really need to bring up a full virtual cluster, because when we talk about the WDS, what I showed earlier on, we really need to run essentially an API server and some annex controller. That's pretty much what we do here. I use the terminology space because that's what we've been using KubeStellar even before we start having this KubeFlex project. But in reality, in KubeFlex, we talk about control plane, really. What we create or what we instantiate in this box is a control plane. And so you're going to see the term space or control plane sort of independently here. There are also different type of spaces. As I mentioned, we support vCluster. So you can run a vCluster if you need to run a pod, for example, in this virtualized kind of cluster. And this is actually used for the ITS kind of space. We also support the default type that is the K8S. So this is really virtual Kubernetes API server with some basic controller. As Andy mentioned before, there are about 20 APIs from Kubernetes we support there. We don't really want to have a very heavyweight API server because we want only to expose the surface that we need for our workload, for delivery the workload to the different clusters. And then we have also other types. We have also a host cluster. So we can also represent, if you want for any reason, actually we have some use cases like this. If you want to run in the same cluster, the so-called hosted cluster, directly use that as a WDS. We have that ability. So that basically the host represents really the hosting cluster. And there are scenarios, for example, we've done integrations with Kubeflow pipelines and Q. In those situations, it's also convenient to use the hosting cluster as a WDS. Because in that case, there is this ability to suspend a workload like a pod and deliver to some other cluster and then run it there remotely. So we actually have an integration we did with Q, similar to multi-Q, but using some of the feature we provide in KubeFlex, including the pool model, a better security model, etc., that allow to use essentially this model with the host cluster. And we have also recently added this capability to have an external, what we call an external cluster. So, for example, if we have a cluster that we want to use as a control plane, for example, one example is an existing open cluster management cluster. We want just to import this cluster and use it as a space for KubeFlex. And so that's the external scenario. We don't really manage or run that control plane within the hosting cluster. We want to import that from outside. And that's now supported in KubeFlex natively. So I just want to quickly talk a little bit about the architecture, how this works. So KubeFlex, of course, to host this API server, we need what we call a hosting cluster. So we start with this hosting cluster. We can interact with the KubeFlex either with a CLI. We have a KubeFlex CLI that is called KFlex. We have also the standard Kubernetes CLI, right? The kubectl CLI. And so the CLI can interact with the API server of the hosting cluster. If the hosting cluster is not already present, we also have the ability to instantiate an initial kind cluster automatically from the KubeFlex CLI. So the user, all he has to do is to install KubeFlex CLI, run a command init, create cluster. It's going to create a kind cluster that is used as the hosting cluster. Once this hosting cluster is set up, if we install, for example, using, I'm going to show an example using the CLI, but Franco here has worked also on basically using a Helm chart to do pretty much everything, right? He's going to talk later about the CLI for KubeStellar. So in this scenario, with the CLI, when we do this init, essentially what happens is that the CLI install, first it creates a namespace, right? In this namespace, it's going to install a database that is used as the backend database for the API servers. And there are a couple of options here. The default option is actually we use Postgres together with Kind. And this allows us to have a kind of a lightweight solution to create a lot of API servers with the same backend. It scales pretty well for this kind of use case that we have. And then also install an operator, right? It's really a set of controllers that are managing essentially the CRD used by KubeFlex. The main CRD is really the control plane CRD. And suppose that now we use either the kubectl apply. We can use, of course, kubectl. This is a custom resource like anything else. So we can just create an instance of this custom resource and then apply that, or we can use just the KubeFlex CLI, right? And that essentially apply this control plane CR. The operator, the KubeFlex operator, is going to see, is going to watch this particular resource, is going to create a namespace for the particular control plane, and within that namespace, we have an ingress, we have a service, we have a secret. The secret is going to be used to keep the certificates and the kubeconfig for this API server that runs within a namespace. And then at this point, the user can just interact with that API server through the ingress, the service directly, right? Just go to that new context using a kubeconfig, interact with like any other kube API server using standard, basically commands in kubectl. If we create another one, it will be pretty much the same flow, right? And we can create as many as we want, as long as we have enough memory CPU on the cluster. These API servers are very lightweight. We're talking about maybe 300 megabytes of memory to run. We don't need a lot because, again, we try to strip it down to the essential. Of course, if you're running vCluster, vCluster is also another scenario we can run here. You need a little more memory, but that gives you also the ability to run pods, etc. Now, some folks ask also, why don't you just use vCluster, directly? The main reason was, again, we wanted to have a very lightweight kind of deployment. We didn't really necessarily want to run pods. There are other components in vCluster we don't need when we run this kind of stripped down API server. And that's the main reason. We want also to have a very abstract way to this notion of control plane to manipulate different type of control planes, right? We could potentially run, we haven't done that yet, but at some point we are looking to integrating, for example, KCP as one of the possible control plane. It's another project here in CNCF sandbox that is getting some attention in the last few years. We also work with the KCP team for some time. So that's another possible option for future work that we contemplated also. Just want to mention something about post-create hooks. That's another feature of kubeflex. So as I mentioned, the idea is we can run this API server, but we also want to run controllers. API server without controllers doesn't really do much. For example, even the KubeStellar itself is running controllers against these API servers that represent these spaces in KubeStellar. So post-create hooks, the idea is that when we create a control plane, we can specify something to run as soon as the control plane come up. So in the CRD, in the CR for this control plane, we can give a list essentially of Kubernetes objects that we can deploy that are attached to the particular control plane, to the particular API server. That's pretty much the idea. And here is an example. We use mastery chart today, but you can also use kubeflex to create the WDS and the ITS in KubeStellar. This is an example how you do that using this post-create hook. Essentially, you specify the type of API server or control plane, and then you provide this option P to say this is a post-create hook. And this is also a YAML, basically, that say what actually is going to be attached to the particular control plane. Okay, so let's see a quick demo how this works. So what is I should do from here? Yeah. So let's assume that we do this from scratch. We just install the kubeflex CLI. So what is happening here is that we say, let's create a kind cluster at the beginning. And so the CLI creates automatically a kind cluster. We want to start from scratch. Because the idea is you can install with Brew the kubectl. So once this is installed, we have the hosting cluster, is installed also all the kubeflex controller, everything. The demo is sped up a little bit. It takes maybe a few minutes to run in real life, but I wanted to just not spend too much time looking at a screen. So what it's doing now is creating an instance of a control plane. So we just say create a control plane or type KTAS. And so what you do, once you get this, you can just run standard Kubernetes command, right? So these are, I'm just going to stop 1 second. So this just the CLI, once it creates the control plane, automatically set the context to the new control plane, to the new API server. And now you can run commands, standard kubectl command against that. For example, here I'm listing namespaces. And this is not the hosting cluster, right? I'm connected now to that control plane that I just created. So that's pretty much what happened here. So I'm just getting the namespaces here. And then actually what I did was I created also a new namespace, right? I created a new space to show that actually there is isolation A namespace, as you know, is a cluster scope resource, right? So if I do this on the hosting cluster, right, every basically client will see the same data namespace. But because I'm hosting now these control planes within that cluster, each one is isolated for cluster scope resource. So I can create a namespace. I created this namespace here as an example, foo. Then I show that it's there. Then I create another control plane. So this is the second thing that I do here. Create a second control plane, and then I also list the namespaces there. And actually, first I go back to the hosting cluster. I show that I have a bunch of namespace there from the hosting cluster itself. And there is also one that is called CP1 system. This is actually a namespace hosting the control plane. So the next step is I create now another control plane just to show that there is isolation. So once I go now to this new control plane, takes maybe a few seconds to create. Again, this is essentially starting a pod with an API server and also controller manager, a subset of controller manager. And I can see now that if I get the namespace, I don't have that namespace I created before, right? I had a namespace foo before I created, it's no longer there because this is a new control plane. And pretty much I can do the same thing, right? I can create another one, this is not gonna interfere with the other one and so on. So that's pretty much the demo that I wanted to show, that we have essential isolation. Here is just to show what we have running in those namespaces. We have, you can see from the bottom, there is essentially an API server running in each one of the namespace for those control planes, and there is also a controller manager. So that's pretty much what we have there. So this was a very quick tour of KubeFlex, what it does. That's pretty much give the idea of what we have there. Okay, so I think I can move. So let's go to some of the issues that we have. We sort of labeled some of these issues. They are also in, I think they are also in the cloud contributor, right, Andy, that you mentioned?
I don't think the KubeFlex ones make it over. It's the KubeStellar.
Oh, it's mainly the KubeStellar, okay.
Yeah, the KubeFlex is labeled.
Okay, so anyway, we have labeled this. There is a link also, I think we're gonna have that in the presentation, but essentially if you go under KubeStellar, KubeFlex, you can find, of course, the issues. And these are issues that are still open, that we label as need help, right? And some of them, we actually got already some contributor, that is great, right? Because I think we advertised the KubeFest even before the KubeCon, so we already got a couple of contributors that have been actually working on this issue. The idea was to give also some quick and easy issue to get started, basically, to get some, to understand the tooling, you know, how you get there, how you do your first PR, that's pretty much the idea. Some of them maybe are more challenging, you know, the idea is maybe get started with something relatively straightforward. We had some issue, for example, in the CLI, there was some feature asking support for listing context in the CLI or for getting the current context, a few other things. And these are some that are still open. We have some issue that I'm not going to go through all this list, but I just wanted to mention that there are a couple that are being worked on right now. And we, of course, we like also to get contributors to help with some of this, right? I just want to mention also and give a shout out to one of the contributors already submitted PRs that we reviewed and merged, Asmit Kumar Rai. He actually contributed so far this PR that are merged, and there are a couple of more that actually are in the pipeline that we are working on. And so, as Andy said, we need your help, right? If you know, you like to jump in, contribute, you know, just go to KubeStellar, KubeFlex, and you're just looking for issues that you like to address. That's pretty much what we have. Okay, so I'm gonna now leave Franco to talk about the other section. Yes. So Franco Stellari is another contributor to our project, also worked with us and has been helping us from the very start.
So thank you for the opportunity, and I want to say that this working on this project has been very nice. I come from a hardware background, and I've been working on Kubernetes and open source stuff in the last couple of years. And working with this group of people was very helpful. They're very supportive, and they are very good in giving guidance. So thank you very much for the opportunity. And I got to come to the first KubeCon for me. So I took, when I joined the project, I actually took ownership of trying to develop an Helm chart for the KubeStellar project. And you can see here some highlights. The Helm chart supports, as was mentioned before, all the type of cluster that support by Kubernetes and OpenShift cluster, and allows to either deploy or reuse an existing kubeflex controller on the chart, and allows also to create a user-defined list of the different KubeStellar spaces that are supported. And we can support all the kubeflex type of control plane / spaces, as it was mentioned. And in some cases, for example, we want to use, as Paolo said, KDS type of chart because we want low resource utilization. And in some cases, we have a cluster like Raspberry Pis with very limited memory where we want to use very low resource utilization. We can also, through the Helm chart, decide to deploy or reuse an existing open cluster management in the ITSs. So this is an example of a basic deployment that we can do with Helm chart. As you see, we reference the KubeStellar core chart with a specific version. I think now we are 0.27.2, I believe. And in this case, we are creating two spaces. One is the ITS one, and the other one is the WDS one. So with very few settings on the command line or in the value file, we can bring up a example of deployment. In this case, we have some default type for the type of cluster. The ITS by default is a B cluster, while the WDS is a KDS cluster. We also leverage kubeflex post create hooks to basically deploy all the KubeStellar controllers that are needed to manage the control planes. So here I'm going to run a simple demo. As you see on the left, you see the pods in the hosting cluster, and on the right, it's a watch of a snapshot script that it's available on the KubeStellar repo that shows the KubeStellar resources. So we apply the Helm chart, and now we say that KubeStellar is populating the various resources, right? We can see the Helm chart was deployed, the kubeflex chart was also deployed, and we can see the realization of the various control planes, and the snapshot script shows the various status of the various controllers and resources being used. Another interesting application of the core chart is the addition of new control plane, new spaces as needed after the initial deployment. So we may be in a situation where we want to add a second WDS space, in this case, a host type WDS called WDS0. And there are two ways to use the Helm chart to do so. In one way, we basically upgrade in place the existing chart called option 1, KS core, and we add the new resources that we want to add. Proceeding this way will redeploy basically all and update the resources in places. A second option is to create a new instance of the chart. And in this case, besides passing only the new resources we want to create, we also need to disable the installation of the kubeflex operator and this post-create hooks. Again, you can refer to the documentation also for more detail. Currently, we are working in integrating the Argo CD into the core chart. we are basically adding values and features to the core chart so that a user can deploy Argo CD along KubeStellar and have automatically register all the WDSs as clusters in Argo CD. Additionally, we can create also simple application in Argo CD so that a new user, for example, can bring up the clusters and bring up, for example, a simple Nginx application example that it can practice with. So this PR is still open. So if you want to contribute or you want to, weigh in your opinion, you still have a chance to do it. So in the development of this Helm chart, there were some challenges, one of which was recently solved, and is, for example, the fact that Helm had, obviously, as expected in the project, some bugs in it, and in particular, it was not possible to null out some values in dependent charts, like in Postgres SQL chart that is called by kubeflex. So in order to work around these issues, we have to complicate our life, and the kubeflex chart, for example, has to create a Helm pre-install hook with a Helm job and customize the chart on the fly to do the installation. So we are also trying to contribute back upstream to Helm to facilitate some of the features that we would like to have available in KubeStellar. So these are an example of 4 issues that were open recently in the Helm repo that we're looking for help to address so that we can simplify some of the feature in the core chart. So if you have experience with Helm and the Helm repo, that would be really appreciated. So thank you very much, and let Andy close.
All right. Thank you, Paolo. Thank you, Franco. Okay, so just in closing, we have a few people we want to thank. So Asmit Kumar Ray, he was able to help us out in KubeFlex. I think you saw that earlier. Let's get started with Bub Mitchell. These are all just shout outs for anybody who's watching on YouTube afterwards. Thank you very much for your help. This is the KubeStellar UI team. These are the 6 plus CNCF folks that are helping us out, the LFX interns, and they're all listed here. So I want to say thank you to them as well. Thank you for helping us get this far. Some of the properties that we have. Okay, if you want to get to us quickly, it's all hanging off our main domain. .io/TV is our YouTube channel. .io/join us is our Google group, and .io/Slack will get you in touch with our maintainers. The 3 main properties that we're maintaining right now inside, well, actually there's a 4th one, and I just left out KubeFlex altogether. Great. So it's KubeStellar/KubeStellar/UI/Galaxy and /KubeFlex. Sorry about that, Paulo. All right. So LFX internships is where you go to apply. Google Summer of Code, that's where you go to apply. And we also are collaborating with teams from Valencia College down in southern Florida. Well, let's see, Orlando, Florida, and Georgia Tech and RPI in the U.S. On internships that are, I think they're supplemented by their colleges and their academic pursuits. But they also will join us on occasion from semester to semester. So thank you. And one last question to all of you. Would anybody like a sticker? All right. Well, thank you very much, all of you, for joining us, and for all of those of you online. We appreciate it, and thanks. And if you can help us out and contribute in any which way or form, we'd really appreciate it. Thank you so much for your time and attention today.